Okay, guys. So just to kind of recap what we had done last class. I'm having trouble getting this to zoom in again. I don't know. It's funny. I find if I come back later and try again, it works. So we'll do that in a second. What we started talking about was specific things related to the sine and cosine functions. And we talked about the fact that they are periodic. In other words, it repeats. And the fact that it repeats and has a specific pattern is going to be a tool that will help us if we need to graph something where there are a few changes. So we kind of went through and we analyzed the specific things that we knew about the sine of theta. If we were just graphing f of x equals the sine of angle x or the sine of theta, we looked at the same thing related to the cosine, and we were able to get that graphed as well. And now we started talking about what all those little transformations can mean on our graphs. So we started with amplitude, and amplitude describes what? When I have a change in amplitude, what does it do to my graph? You can have basically the concept of a vertical stretch or a vertical shrink. It makes my graph kind of spread out taller, or it might condense it and make it look not as tall, not as yeah, we'll use tall, as the original. Now, what we did last class, why is this not zooming in? Okay. What we did last class is we recognized that as long as that shows up right in front of the function, if it's the first thing I see after the negative sign, let me see if I switch over this way, maybe that'll work. Okay, then that means that this is related to either that vertical stretch or vertical shrink, and that's my change in amplitude. Now, if it's a number that's between 0 and 1, it shrinks it, right? So it's only half as tall as the original. If it was a number that was larger than 1, what would it do? It would stretch it. And so what we figured out, hopefully, is if that's the only change in my graph, then as long as I know how the original graphs, I can make that adjustment. What's the normal period for a sine function? And by that, I mean 1 complete cycle is how long? 2 pi radians, right? So it starts at 0 on an axis. We know a hala helps us know how to graph it. It ends at 2 pi on an axis. And so as long as we know all of those key points for a sine function, we would just multiply every one of these by 1/2 to see what it looks like when it's been shrunk by 1/2. If it had been a number that was larger than 1, then we would have multiplied everything by that number, and it would have stretched out on the high point and the low point. But it would follow the same basic shape, just either be a little more stretched out or it would be shrunk. So this was the rule for amplitude. Should that be easy for us to deal with? I think it is, as long as you recognize if it shows up right after the equal sign in front of your function, that's when it's a change in amplitude, okay? Now, we're going to talk about what happens when the period is different, because this is where we stopped last time. And we said that if you see a number not in front of the function, but only in front of the x, so in other words, it's affecting my angle measure. So if I see sine of some number times x, then that number is going to change the period of the function. In other words, it won't be 2 pi anymore. Now, in order to do this what I think would be the easier way, I want you to turn to this page of notes, and we're going to actually fill this in before we go to the graph. So if you have some value of B, which is a positive number, okay, then your graph is going to be the same as what the original sine graph is. But here's how your period changes. A normal period is 2 pi, right? Divide it by whatever B is, okay? That will give us the new period. Same thing's true with cosine. We would just take 2 pi divided by B to get our new period. All right, so does that make sense? Now let me show you how that's going to help us on the graphing. So let's look at this guy up here. And what it says is we want to graph y equals sine of 1/3 x, and then we could compare it to the sine of x. Now, in order to do that, I don't know why this thing will not. Let's see, maybe if I do this. Oh, that was not good. Okay. Hold on, now I messed up. Okay.